This is the review for the Chapter 15 quiz for Algebra. In question number 1, it says graph and label the function. Make sure that you label your function. A very, very common mistake in this section is to not label it. Make sure that you label it after you graph it. Now, you are graphing a piecewise function. You are graphing the absolute value of x plus 1 from only -4 to -1. So only from here to here are you graphing that first function. So one of the ways that you can figure out what to do is to type it into your y equals, all right, to figure out your points and do second and table. Remember that the absolute value symbol, you have to hit second and 0, which is the catalog, to get this ABS, which is your absolute value. Then type in your x plus 1. You need to tab out of it by hitting the arrow pad and then do plus 1 again. So now that we have that equation typed in, you can hit graph and see what it looks like. But remember, we only want it in between -4 and -1. I would hit second and table to find your points. You're going to have to go up in your table. So -4 is 4, -3 is 3, blah, 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 blah. Remember that an or equal to symbol is a closed dot, and a not or equal to symbol like this one right here is an open dot. Remember, sometimes the graphs will connect and sometimes they won't. It all depends on the individual graph. Sometimes you will have arrows on the end, sometimes you won't, all right? So at -4, it says or equal to. All right, so we're going to put a closed dot at -4. Let me just erase some stuff on this graph, make it a little bit nicer. All right, but we're only doing it in between a -4 and -1. So -4 is +4, and that is a closed dot there. At -3, it's 3. At -2, it's 2. At -1, it's 1. But remember, it is an open dot right there at -1. So it's going to be an open dot right here. Connect the dots. That's the only part of the graph that we want. Now, we don't want an arrow on the end because it starts at -4. All right, this is where our graph, this is where our graph starts. All right, it starts at -4. So that's the only part. And now we need to label our graph as well. F of x equals the absolute value of x plus 1 plus 1. So there's our first part. Our second part of our graph, and I'm going to switch colors so it's a little bit easier to see, says the f of x equals 1. So if I go back to my y equals, I clear out that equation, it's just f of x equals 1. All this is a horizontal line at 1. And we want it from -1 to 0. If we do hit second and table, you'll see that all those values are 1. But we want to start here at -1. So -1 is 1. Over to -1, up to +1. Now this is a closed dot right here. So I need to do a closed dot. The closed dot trumps the open dot that's at that same spot. And then I have it going to 0. So it's only going to here. I'm just going to connect right to here to here. All right. And again, this one is a closed dot at 0 as well. So this part of the graph is just f of x equals 1 when I go to label it. For the third part of my graph, I want to graph x squared plus 1. So if I go to y equals and I type in x squared plus 1 and hit graph, this is what the graph looks like. But now I only want it for values that are greater than 0. So when I hit second and table, I'm only going to have it from here on. So second and table, I only want it starting at 0. So 0 is 1. Now be careful. This right here says that it's going to be an open dot, all right, the greater than symbol. So at 0, it is 1. That's an open dot, but that closed dot trumps it, all right? And then at 1, it's 2. And then at 2, it's 5. And then I end. But be careful on this one, it's going to be an arrow at the end because it's not stopping, all right? There's no stopping point on that. Some graphs stop, some graphs don't. If this says x is greater than 0, it keeps on going. We want all the values that are greater than 0. And then you need your f of x equals x squared plus 1 label. So again, sometimes these graphs will connect, but remember, sometimes you might have a graph that goes like this, all right? But then maybe start an open dot and goes like this. Sometimes they don't connect. So be very, very aware of that. But that's not part of this graph, all right? So that's what that one looks like. What is the domain of the graph above? Remember, domain means x, range means y. They go in alphabetical order. X comes before y, just like domain comes before range. What are the x values of the graph? Now, because of what we did in a previous chapter, you might be thinking it's all real x. It's not all real x. Our x values start on our graph right here at -4. Do they keep on going over to the right? Yes, they do. So we want everything from -4 on up. So it's going to be choice A, because we want all the numbers that are bigger than or equal to -4, because it keeps on going over to the right. The range are your y values. The lowest part of our graph is right here at 1. Does it keep on going up? Yes, it does. So that's going to be choice C. We want all the y values that are greater than or equal to 1. Make sure that you remember to label your lines there. In question number 4, which function represents the graph below? Now, when I look at this, I see that all of these are all the same. All right, so there's no difference there. The only difference is in the equations. Now, I know that this one is hard to see a little bit, so I'm going to make it just in purple. I'm just going to trace it in purple here. There is a line right there, and this is a closed dot right there. So I know that the second part of this, it says it's either going to be a -2 or it's going to be a +2. This line right here is at -2. So I know that this part is wrong and this part is wrong. That narrows down my choices. Now I need to figure out that top part of the graph. That top part of the graph is either going to be x plus 5 or x minus 5. Well, there's a couple different ways to do it. The way that I would do it is I would go to my y equals, type in x plus 5. When you hit graph, you get this picture. Does that match this part? Or if I type in x minus 5, and I'm just going to do it again, here's x minus 5 down below, does it match that picture? Well, this graph clearly, if I keep on going with this line, if I extended this line out, it's crossing at +5 right here, not -5, all right? -5 would cross right here and we'd have a line like that. All right, so it's not -5, it's +5. So this is choice A. In question number 5, which translation occurs when the f of x equals absolute value of x is transformed to absolute value of x plus 2? What does adding 2 to the entire function do to it? Which way does it move it to? Well, if you don't remember the rule, which I'll talk about in a second, you could always take and type it right into the calculator. Type in the absolute value of x, and then type in that second equation also, the absolute value of x, tab out of it, plus 2, and hit graph and see what happens. Look at the min. All right, what happened from this blue graph, which was our first one? All right, you know that it's the first one because it's the first one in our list here, the blue color. What happens to the min going from here to here? Well, it went up 2. You could do the same exact thing and by the way, adding 2 to the whole thing makes it go up. All right, subtracting 2 to the whole thing makes it go down. All right, if that was a -2 there. If it was inside the absolute value, that's when you're going left or right, depending on whether it is plus or minus. Always double check it by graphing though. That's a safe way to do it. In your question number 6, you have the absolute value of x, and then you have the absolute value or negative, I forgot to hit negative second catalog absolute value of X. So now we have this equation, all right? What happens when we have a negative sign outside of the absolute value symbol? There's our original one in the blue. Here's our new one. What happened there? It is a reflection over the x-axis. It's never going to be a reflection over the y-axis. This is the x-axis right here. It's that flipped opposite mirror image over the x-axis. Take a look at question number 7. In question number 7, which step function is represented from 0 to 4 here? Well, when I take a look at this, I see that all of my numbers are all the same. What's different are the symbols. Remember that if it is a less than symbol like this, it's going to be an open dot. So here I have an open dot and an open dot. Does my picture show open dot, open dot? No, it shows open, close. So we know that one's not right. This one would be open and then closed. Does it show open, close? Yes, open, show, open, close, open, close, open, close, open, close. That's my answer. It would not be choice C because this says closed, then open. That's not what we have. This one says closed and closed because of the or equal to. That's not our answer either. Question number 8 is definitely the hardest question on here. All right. In question number 8, it says an online website has shipping rates for the following. For a package that weighs no more than 10 pounds. Well, that means it's going to be less than 10 pounds. All right. If it's less than 10, we could just write it like this. It's less than or equal to 10 pounds. And it's going to cost a total of $5. Now, you could, if you wanted to, go like this and put the 0 is greater. In order for something to be shipped, there has to be some sort of weight to it. So it has to be greater than 0. So you could write it just like that. Then the second bullet says between more than 10 pounds, but no more than 20. No more than, so it would be 10 is less than X, which is less than or equal to 20. It can weigh 20. All right, that's why it's or equal to. It just can't be more than 20. And you're going to get charged $10 for that. In the third bullet, no more than 20, but no more than 30. More than 20, but no more than 30. And you're going to get charged 15 pounds. More than 30, but no more than 40. And you are going to get charged 20 pounds. That's what it looks like. You only have less than symbols here. You have to make sure that you have your inequality statements, but you also need to make sure that you have your what you're graphing as well, like how much the cost is of it, because you need to know what to graph. So when you go to graph this step function, all right, remember step functions look like this. All right, so that's what your graph should look like. It says graph the function, be sure to label your axes. Time, remember, always goes at the bottom. Well, our time here is really our weight. All right, this is going to be the weight here at the bottom. This is going to be the cost over to the side. Your dollar amounts always go over to the side. So we have 0, we have 10, we have 10, we have 20, we have 30, and we have 40. For the cost going up along the side, I have to start at 0 here. And I'm just going to count by 5s. 5, 10, 15, and 20. 20 is my biggest number. 40 is my biggest number. So that's how it looks laid out. Now I need to graph it. Remember that these are going to be open dots. These are going to be closed dots. So from 0 to 10, it's $5. So 0 to 10 is $5. I'm going to put an open dot here. I'm going to put a closed dot here and connect them. From 10 to 20, it's $10. Open dot here, closed dot here. From 20 to 30, it's $15. Open dot here, closed dot here. From 30 to 40, it is $20. Open dot here, closed dot here. That's what our step function looks like. Pay very close attention to this part, all right? You have the inequality statements, but you also have to know where you're graphing it. Very difficult question like that. Remember, time always goes down at the bottom. In the last question, what type of translation goes from absolute value of x to the absolute value of x plus 3? Again, I'm going to go back to my graph here, and I'm just going to change the second one. So second catalog, absolute value, and I'm going to have x plus 3. When you add x to just the x, or sorry, when you add 3 to just the x value, take a look at your min. We go from the blue to the red. It's going to the left 3. It would be to the right if this was a minus sign inside the absolute value symbol. And that's your quiz. All right, pay close attention to number 1 and number 8. Those are the two hardest questions.